Today we're going to multiply and divide our integers. You can read more about why it works this way and what the number line looks like on your own. I just want to go through the examples and tell you what they are. In letter A, we're going to multiply because I see parentheses next to each other. That's one way to show that operation. Multiplying negative 10, and negative 5. And these are called integers because we have negatives, and wholes and counting numbers don't include the negatives. So these are integers now to the left of the 0 on the number line, right? Because they're less than 0. Okay, when we multiply two negatives, just a rule, multiply a negative by a negative, and you always end up with a positive. Okay, so 10 times 5 is 50, and then check your signs. If it's negative and negative, keep it as a positive 50. What's fun is the product is the same, you just change the sign. But when you have different signs, like plus and minus, it stays minus. So two wrongs make a right kind of deal. Same with division. If you divide a negative by a negative, it becomes positive. So just forget the signs for a second. Do 10 divided by 5 is 2. Then check your signs and realize, oh, it's a positive 2 or just 2, right? 10 divided by negative 5, just like with multiply. When we did that, it stays negative when you only have one negative involved, not two canceling out. In this example word problem, every month $25 gets deducted from his checking to pay for an internet direct withdrawal bill service, bill pay. Write an expression using integers that shows the effect on Newton's account of 6 months of charges. So 6 months times what? Times 25? Or should we say negative 25 because it's a withdrawal from his account? Okay, 6 times 25, first of all, is 120 because 6 times 2 is 120. But then 5 times 6 is 30. So 120 plus 30 is 150. Now, I have a positive and I have a negative. When there's only one negative, it's a negative, right? And that makes sense because we're losing. Overall, it's a negative net change. Negative 150 looks good. The product of two negative numbers is always a positive, so when you square to a negative number, which really means timesing it by itself, that's really then going to always turn positive. So negative 5 squared means positive 25. But if you cube, that really means 3 times. Now when you do that, this really becomes positive, right? So you have positive 4, then you've still got your negative 2. And well, now you've got a positive times a negative, which we know stays negative. Negative 8. So when you have 3 negatives, it stays negative. But 2 negatives means positive. So it's if you have an odd number of negatives involved in the multiplication or division, it stays negative. But an even number of negatives means turns positive. However you want to write that shorthand, or if you just remember it. So to the 5th means that I'm going to have an odd number of negatives. That's going to stay negative. I don't even have to write it all out. Negative 1 times negative 1. You could do that. You could start grouping them up and saying, okay, I got 2 here, and then I'll have 1 left over, which means it's going to stay negative. But you can just see it's an odd number. Odd number of negatives means negative. Odd number of negatives means negative. But then the even number, like to the 6th, really means times itself 6 times. They're going to all even out. You're going to have a positive final squared answer. So in example A, if x is worth negative 2, we put negative 2 in there. What is y, if that's what it is? Well, an even number of times means positive 4. But in this case, x can be 2 numbers, can't it? It could be positive 3, or could it be negative 3? Well, when you square something, it technically does become positive. We could have solved example 4b by finding the square root of x squared and 9. Just going like, what's the square root of this? What's the square root of this? I think we've done a little bit of that. The radical indicates the principal square root. which is the positive square root. So if you ever need to find the square root of x, assume it's positive. So even though, yes, -3 technically is an answer, we'll generally say, well, it's +3. We're going to assume that. So here's some rules to remind you how this worked. You can do a little activity about reversing signs on your calculator. Use that little plus, minus, slash sign right here. You ever use that? And other things. We added and subtracted our terms in lesson 31. When you multiply and divide terms like this, it says we can use the commutative and associative properties to help us. Everybody's favorite. So because it's all commutative and such, we can group the constants together and say, well, that's -12. And then do your x's together right here. And that's x to the third. Y squared. And there's just this lonely z from here. Okay, so they kind of group it all up. You'll do that kind of in your head. And when you divide, you can kind of do that too. Reorder them so that the x's are above each other. The y's are in, everything's in the same order. Basically, I always go alphabetical, x, y, z. Okay, and then it's easier to cancel or group up products and stuff like that. To expand in example 6, we do 3x times 2x, which is 6x. Don't forget the squared. Because now we're not just adding to get 5x. We're doing 3 times 2 and x times x and put that all together. Then we do 3x times -4. And that's -12x or -12x, okay? You get 6x squared minus 12x. Well, how about this one? Remember what we know. What's this? -6x squared because of this negative sign. But then keep the negative, do it times -4, and you get positive 12x. What do you think about that? Why don't you quick do all of these because they should be quick if you're getting it. And if you're not getting it, it's important I find that out now. And then do letter M, please. Thank you.